Hello, my name is Christopher Leuer, and this is my presentation on Neo4J. My project is to represent 120 years of Olympic data history in graph form using Neo4J. The challenge is that there is 270K data points representing Olympic events for athlete participation going back 120 years. And how do we present that in a meaningful way, a user can interact with the data set? So I chose to display this using a graph and persist the data in nodes and relationships in Neo4j. So here we have a game, an event, and an athlete. These are nodes. The athlete has a relationship with the event, whether or not they got a medal, gold, silver, or bronze, and the game hosts the event. So I wanted to build an application that's scalable, that can deploy in the web, that many users can interact with. So I decided to make a web application. I decided to use Spring, in particular Spring Boot, because it's a scalable JVM-based framework that has a skeleton that allows me to quickly generate the project. Of course, I chose Neo4j to represent the data in graph form. And to integrate that with the web application, I used Spring Data Neo4j, which is a library, and the library allows the programmer to create an object graph model, basically classes that map to nodes and relationships in the Neo4j database. I programmed the app in Groovy, which is a JVM language, just like Kotlin or Scala or Java itself. It's an expressive language, has some pros and cons, but it worked well and integrates with Spring and Java. I chose D3JS as the visualization tool. I think that's the best one. It's the most powerful, and there's a lot of good examples, but it requires a lot of work. Okay, there were some support technologies involved. Spock for testing, that's Groovy based. I found a nice little parser, which I referenced in my doc. Basically, the parser just reads the CSV data for me. And this all sits on the Java platform because Spring is Java. Uh, when In order to build the application, I chose Gradle over Maven. It's just a little more declarative, and it's Groovy based. And what's useful about this to you as a programmer or as a potential user of my project is that you don't have to install any of the libraries. It will download all of these dependencies for you when you run the application. So this is a list of all the dependencies for the application right here. Okay, here's a quick screenshot of what the visualization should look like. Basically, we have a D3 visualization running on a Spring Boot web application backed by a Neo4 database where all the data is stored in nodes and relationships. And we want to add some features like the ability to hover over nodes and get information about those nodes. Okay, the data source is a really nice data source I found on Kaggle. It's 120 years of Olympic data for medal events, not all events, but the final rounds. And it's one line for every participant in the event. And it's got about 270K, 270,000 plus lines that need to be read. It took about 9 hours to load them into our system, and you can see an example of the data set down here. So basically, we're going to derive the game and the event and the athlete nodes from the data set with the corresponding properties. So the steps to create the project. Basically, you download a Neo4j database. That's pretty straightforward. It's just a tarball. You run it on your local Mac. I had no problems with the server. I just increased the heap size just in case there was any issues, but I didn't have any. For the web application, as I mentioned, I use Spring Boot and the Groovy language. And the important part about that is there's the Spring Data Neo4j layer, which is a library that allows us to interact as programmers with the database in an abstracted way. And that actually uses the object mapping model. This will allow you to basically map your domains to the database graph, if you will. And this is very much, if you're familiar with the Spring JPA, this is the same pattern. Okay, a little higher up in the stack, I created the service to load the data rather than choose to use the CSV loader. I wanted something that was idempotent that I had a little more control over. That took a little more time. I created a service and a controller to provide endpoints to return the JSON schema. And finally, I created a visualization in D3 to draw the directed force graph. And then I ran the application. Okay, so here's a little snippet of code from the project. Basically, what you're looking at here is a node and a relationship in Neo4J represented as domain objects in my Spring application. So you have these nice node annotations that do what they say. So you have a node entity annotation and a relationship entity, and the event is a node, and the result is a relationship, and you just annotate these classes. And by the way, you can do this many ways. There's some flexibility here. We have a relationship defined within the class, which is a set. So an event has a set of results. And then here we have a result class with a start node and an end node. So the start node is the athlete, and the end node is the event. And finally down here, in order for you to actually interact with the Neo4j database, and if you're familiar with Spring JPA, you need a repository. So the repository is simply an interface that you might add some custom queries, whether you need to update something in the database, persist a node or a set of nodes or a full graph, or whether you want to run some custom queries. And the nice thing about this repository, it's based on the CRUD repository of Spring Data, and what you'll find is that you can actually inject cipher statements, native Neo4j queries into this repository. I didn't really need to do that, but it's a useful feature. Okay, a little higher up in the stack, you have a service responsible for talking to the database and building the graph, and then a controller which accepts requests from the browsers. And in order to do this correctly, the REST endpoint has to return a JSON payload in the D3 schema. So you have two properties. You have a nodes and a links property, and it's pretty straightforward. You have indexes. These are just informational indexes. I put those in there so you could see them, but it uses the order. But basically what happens is for D3 to actually render the visualization, the D3JS force library to render the visualization, it will read this content and it will map each node to another node by the links array. In this case, we have an event mapped to an athlete down here in links. Okay, what does the visualization look like, and what capabilities did we get with D3JS? So I created a draw function which will allow the user to interact with the D3JS visualization and basically ask for different data sets. You can't just load 270K data points into the browser. You could barely load like a whole Olympics data set for like 1 year into the browser. So this is sort of what you need to do, is you need to create an endpoint that supports querying the data, and the draw function would basically map all of the nodes and links together, and on its own, using its own magic, its own internal algorithms, draw these links. It chooses the X and Y coordinates based on what it thinks is best, based on the relationships. So the features that I added were some coloring and tool tipping and things like that. And also, this is something here you'll notice is that the links themselves are color coded according to what medal people got. So gold means Tiffany here got gold in the swimming event, women's 400-meter freestyle. Okay, here's a snippet of code from D3JS. I won't go into too much detail here, but I'll just point out some interesting things. The way that D3JS works is that it basically matches all of the data that comes back here, way down here on this line here that has a graph. That's the data that comes back, and the graph has nodes and it has links, and that data is mapped using the D3 Force library to SVG elements. So every time a user hits the submit button, this draw function will execute and then redraw the visualization on the fly. Okay, here's another screenshot. Here's this filtering capability. So one of the important parts about this visualization is let people drill in and look at individual sports and also ask a question, who medaled in an event? So we can do that with these inputs. Lessons learned. D3 is a very powerful tool, but it requires a lot of experimentation. I found that Neo4j as a database worked flawlessly, but the actual Spring Data Neo4j library had some idiosyncrasies and potentially a bug I ran into, so maybe it's not as fully or widely accepted as Spring Data JPA. But otherwise, it was actually very easy to program in, and it alleviates the need to actually write Cypher queries, it's very useful. It basically creates this nice abstraction layer for you where you don't have to actually program in Cypher. I would say optimization is needed to make the queries run a little bit faster, potentially do some caching, and the data load ran for a while, as I mentioned. Groovy and Spring Boot both proved their worth. I think that they were good choices for the web app because they are easy to program in and reliable, and I had no issues with the service. How do you run it? I actually have a GitHub repo up there that provides these instructions. It's really simple. You just need to change your, start your Neo4j database here with the Neo4j command, and then run this Gradle command that will actually start the application on port 8090. Okay, I would like to publish this in the future so many people can interact with this data set, but I'd like to make some improvements first. Maybe add filters for athlete and event names and some caching to improve query performance. Okay, let me demo this real quick. Actually, this is good. I think I have the application already up and running. So yeah, there's the visualizations, but let me show you the application first. So the application started, and it'll tell you when it starts how many nodes it actually found. So yeah, right here it says 50. There's 51 games over 120 years, 6,000 over 6,000 medaling events, and over 130,000 athletes. And the nice thing about this, the way I structured this project here in the application property file, you can define which data set you want to load. So if you just bring the project down, it's only going to load a couple data points. You don't have to wait 10 hours to load it. As far as project structure goes, this is IntelliJ is my IDE. This is a Spring application. So if you're familiar with this Java programs, it has this pattern here where we have controllers, basically MVC model. We have a controller. We have domains for everything, and some of these are just enums, enumerations. We have our athlete event, we have our game. We have our athlete, we have our event, we have our game, and then we have our repositories to interact with those and save those to the database, as well as a sophisticated service, actually two services, one to load the data and one to actually build the graph. So there's a very large data service here which actually will build the JSON payload for us. Anything else to note here? No. Oh, there's a little test that will run in the background if you want to just make sure that the service is working correctly. Okay, so let's take a look at the visualization. Yeah, so this is the default that just loads by default for 1984 Olympics in Los Angeles. Actually, I was there when I was 8, so that's why I set this as the default. And we could put an optional sport in here. Let's just choose swimming. Swimming has a lot of events and medal rounds. So let's see everybody who won a medal. So what's happening actually here? There's a lot of events it has to draw. So it's going to make a request to the Neo4j database, and it's going to do a deep search. So it starts at like a top level node and then looks through the leaves to bring back all of the related nodes. So in this case, at the center we have the 1984 Olympics. We have every event color coded. So blue is like a sports group, and then men are blue, women are purple. You can hover over them and get a little information. You can find out who medaled in the event, find out which city it was in. And again, this is a force directed graph. What that means is you actually can play around with it. You can move these graphs around, as you can see, so you can have a little fun with it. And maybe if you have a really busy visualization, it lets you kind of highlight something. Okay, let's try something a little more modern. Let's go all the way up to 2016, summer, and let's maybe take a look at cycling. This will be everybody who has medals in 2016 cycling. So it's thinking, oh, there it goes. Okay, so there were a lot of events. And the nice thing about this is these lines have been color coded. So bronze, it means you got a bronze medal. Gold means you have a gold medal. And you can see who our medalists are. And the other thing is you can go pretty far back with this data set. You can go all the way back to like the year 1896. But let's go back to the Paris Olympics. And let's look at athletics. So who got gold in track in the year 1900? So this is obviously a smaller data set, so the response was faster, and we can see all our medal winners. Here's some winners with multiple medals. So here, this athlete had 4 Olympic golds. Okay, thank you. Oh, by the way, if you're interested in bringing down this project and executing it and running it or looking at the code, I have a GitHub account here, and it will has instructions on how to clone and start up the project and run the application. Thank you very much.